Hi, folks. Welcome to NMA Academy's career panel on academia. This career panel is focused primarily on the students and TAs in the computational neuroscience course, but of course all are welcome. There is a simultaneous panel happening that's focused on deep learning. So if you think you're supposed to be there and you would prefer to be there, you can navigate to the schedule in the upper left-hand corner and pick a different button than this one. But for those of you who are supposed to be here, welcome. We're super excited to have our panelists with us today. Before I let them introduce themselves, I want to remind you that we are collecting your questions in the Ask a Question area at the bottom of your screen. So feel free to ask a question. And if you don't have a question, that's fine. Maybe you'll think of one later. But if you're here, we'd really love you to vote on the questions. That way, the question that you find most interesting is one of the ones we get asked. So ask a question, vote on the questions that are down there, and we'll go ahead and get started by introducing ourselves, and that will give you guys time to ask questions and vote on questions. So I'm going to go ahead and go first. I'm going to be the moderator for this session. My name is Kate Bonin. I'm a faculty member at Indiana University. I study visual neuroscience. I'm particularly interested in sensory motor processing. I use human behavior and neural modeling in order to study questions related to visual perception and how we move our bodies and use our sight to move our bodies. So with that, I'm super excited to have three excellent panelists with me here today. I'm going to go ahead and let them introduce themselves. We might have one panelist also joining us a little bit late. I hope he will join us, but if he does, we'll allow him to introduce himself then. So I'm going to go ahead and get started with Chris.
Great, thank you very much. So my name's Chris Eliasmith. I'm a professor at the University of Waterloo in Canada, about an hour west of Toronto. I hold a Canada Research Chair in Theoretical Neuroscience, and I'm the founding director of the Center for Theoretical Neuroscience here. My research has focused very broadly on developing sort of theories of neural computation, and more recently, trying to build large-scale integrated models of the brain. So we built some of the world's largest functional brain models out there, tend to try to make them, as biologically realistic as feasible, given computational limitations and so on. But that's really been one of the sort of core focuses. More recently, we've been looking at the relation between some of the techniques we've developed for understanding how biological brains work and applying them to various deep learning and machine learning types of problems. Also branching out, looking at neuromorphic computing, working with various kinds of hardware as well as robotics.
Thanks. All right, Judy.
Hi, everybody. My name is Judy Fan. I'm an assistant professor of psychology. My lab is somewhere in transition between University of California, San Diego, and Stanford University. And I am really interested in what makes human cognition so special. So the approaches that we use focus on building computational models and measuring behavior that pertains to the question of, how it came to be that humans, among all the species on the Earth, created, say, symbolic systems to communicate with one another and teach one another, and how people use physical representations of thought, including symbols, but not limited to those, including prototypes, and a variety of other kinds of durable objects in order to help them think, learn, imagine, and collaborate. So a lot of the questions involve connecting the kinds of topics in high-level cognition, including reasoning and planning and problem solving, and how they ground out in sensory systems and action selection.
Awesome, thanks. And last but not least, Ken.
Hi, I'm Ken Miller. I'm a professor of neuroscience at Columbia University and co-director, co-founder of our Center for Theoretical Neuroscience. And I work on, theoretical neuroscience generally, but particularly I focus on understanding the circuitry of cerebral cortex, and more particularly, mostly visual cortex I focused on. Interested in understanding the structure of the circuitry, the mechanisms by which it operates, and what computations those do, and how it develops, how it learns. So that's been the focus of my research.
Awesome, thanks. So I'm going to go ahead and get started with one of the first questions. The question is from a student named Iwei. And the question is, what's the most important quality a PhD student should have? What qualities do you look for in the PhD students, for instance, that you recruit to your labs?
Do you want us to just blurt out answers, or would you like to point to one?
You can go first, Chris.
You started talking. It's your turn. All right. Well, I will blurt out an answer. Yeah. So students often ask me this question, and my brief answer is essentially self-motivation. So I find that the students who are most likely to be successful are those who are driven by a question. Like there's something that they really deeply want to know and are interested in, and that is what makes them want to do the work. So they're not trying to do the work to satisfy their supervisor, or to satisfy, course requirements or whatever. It's just that this is a really cool thing that they find super interesting. That's a very difficult thing to read off of a resume or a CV, or I think as a student to communicate in a compelling manner. The best evidence is essentially going to, just sort of see projects and how deeply you can talk about them and how passionate you are about the various kinds of work that you've done.
Yeah, it's very hard to say. Ultimately you want somebody who is, just as Chris said, self-motivated and smart and creative, and it's more over time you find that they are coming up with thoughts that are and results that are interesting and surprising and get you excited. So it's hard to tell in advance. It's something that develops over time, that you see just somebody is, if they're good at this, that's what it comes down to. And it's hard to define exactly what makes that happen. Certainly resilience is part of it. That you work hard even when things don't work, you keep trying different things. You don't give up. It's hard to say beyond that.
I think I agree with everything that Chris and Ken have already said, and maybe related to that is, related to the questions like, how do you communicate your self-motivation and, resilience in an application or an interview, is like, have you demonstrated your ability to be really proactive in your context? If you, have you taken advantage of all the opportunities available to you and like found some way, like you're here today, right? If you're here at NMA, that's like an example of that, like seeking out every possible way to learn and grow and figure out, how to get to where you want to get to answer the questions that you really care about. Like just by being here, that's already demonstrating that kind of drive.
Awesome. All right, so the next question is, what skills should we focus on during our PhD training if we're aiming to stay in academia? And then perhaps more broadly, what kinds of skills do you see PhD students focusing on if they're trying to leave academia? Since we are academics, we train all the PhD students regardless of whether they stay or leave.
For you in the same order?
Why don't you go first this time, Judy? Oh, you liked that order. I see. I'm sorry.
I mean, we can switch it up so it feels more organic, I suppose.
Yes, you guys can jump in as you feel.
Okay.
As you feel moved, and we'll sort it out if you run into each other.
Right. So the question is broadly, in the area of computational neuroscience, what kinds of skills are important, you think of as being important to cultivate, especially if you want to pursue a long-term career in the academy? Like the most obvious ones are the skills that you need to conduct your research, which will vary depending on the problem that you're working on, of course. So I take the question to really be about those other non-obvious skills, right? Including, communication and collaboration and time management. Actually are ones that I think a lot about these days, where a lot of the work going on in my lab and kind of around in our collaboration networks involves coordinating highly technical work across multiple teams, and being in a position to be able to track that and think about how the pieces fit together as part of a strategy for addressing a scientific puzzle is you know, it's not something you need to come into grad school obviously with, but be attending to, because if you intend to stay in academia long term, you will be a leader, and your job will be to lead and to help guide others. And so thinking about giving yourself opportunities and seeking out opportunities to cultivate those skills, to work well with others, communicate clearly with your peers and mentors and others about your work and its significance. You know, those skills are really important. And time management may seem like something that is useful in all walks of life. I think it likely is. But it really, I think, comes into focus as you enter a PhD program, because unlike many of the other educational experiences you may have, where there's a lot of structure and there are very clear deadlines, the word landscape is really dense, right? You get a lot of feedback. PhDs aren't like that. You often need that self-motivation, resilience to get through the day. And the problems and tasks don't come to you on a platter, well-defined. You don't get a syllabus every quarter or semester that tells you what you're supposed to do when things are due every week. To some degree, you'll have to discover those and create those sub-goals for yourself in conjunction with your mentors, of course, and your collaborators. But I think that like figuring out how to translate your goals and curiosity and desires into plans for action and begin to calibrate your forecasts about how long those take is like so essential, and not obviously part of the curriculum in any explicit way, but can have a lot of explanatory power when you're thinking about like, you know, who tends to flourish in these really open-ended environments. So
yeah, and very briefly, I think what you say really speaks to me as a person that's sort of just moved from a postdoc into a faculty position, because it isn't that you like learn time, if you learn time management in graduate school, like you're done. It's that as you move through academia, you're changing levels, you're becoming a leader, you're working on broader scopes. And so you have to like develop new skills in that area. So really what you describe is kind of like the first step. Can I manage my 1 to 2 projects and the collaborations that are happening within my lab that I am a part of? And then as you get older, it gets more complex.
Yeah, in terms of, I mean, I agree with everything that was said, and there's all of these sort of intangible skills that you need to learn, and you can work on them to some extent in presenting, communicating, being able to give talks, learning how to write grants. But then in terms of technical skills, as Judy said, it's you know, the first thing is just what you need to learn today to do your research today, and that you never stop, you never know it all, you never stop learning, you never, any piece of new research, you have to learn something new to do it, otherwise it would already be done. So, but beyond that, I guess I would just say for theoretical neuroscience, obviously the more math background you can get and the more programming chops you can get, those are both incredibly powerful and useful to you. In terms of leaving academia and going into industry, today, deep learning or machine learning is obviously what you want to learn. Tomorrow, it might not be true, but it looks like it'll be true for a while anyhow. So the math is maybe less obviously what people use when they go into industry, but it probably depends on the industry. But in academia, you definitely want, the more math you know, the better. And what you really want is you want to get to the point where you can learn whatever math you need to learn, so that you feel like you know, where you have enough of a background that that you can then, you know, you feel confident to go and learn the stuff that you need to learn.
All right, I'm going to push to the next question. Do you think there is a good compromise between experimental and computational neuroscience, or do they represent distinct career paths in practice? So I think this question is probably getting at, as a student goes through their training, is it practical to imagine oneself working both on experimental and theoretical, or computational neuroscience simultaneously, or do we think of them as distinct career paths, or is the answer maybe both? It could be a mixture. You could take a path that's a mixture, or are they distinct?
I'll take a stab at this one. And the reason is that I basically, this is something that people have been asking forever. So, my 25 years is like somebody doing theoretical neuroscience. I always have run into people who want to do both. And I think there's really compelling reasons to want to do both. If you as a theoretician, you might come up with the perfect experiment that if only you could do it and you can't get anyone else to, then it would answer this really important question for you. Or as an experimentalist, you've got all this wonderful data and you want to have a much better, sort of deeper understanding, and so you need a model. And I think the sort of disappointing answer is that everyone I've ever talked to who's tried to do both has had to pick one. It's just kind of never managed to be successful doing both. And to me, the strongest people who are doing either theoretical or experimental stuff have some experience with the other one. Like that's perfect. But to actually fully try to do both, it doesn't seem to be something I've seen anyone accomplish successfully. And I've seen several people try, very smart, very talented people, but in the end, it just seems like it's not really the kind of thing you can balance very well. You can have a lab that does both, but just as an individual, it's extremely difficult to do. And even if the lab does both, there's always a clear emphasis typically. So I know that's not the answer people really want to hear, but that's just from my experience anyways.
Yeah, I agree with that. I think experimentalists can be very computationally knowledgeable and savvy, and that's very useful. It's not unusual for experimentalists to have theorists in their lab working with them. And the more you understand the theory yourself, the more effectively you're able to mentor those people and work with them. And the more effectively you're able to collaborate with other theorists. So I think they're very computationally capable or theoretically, knowledgeable experimentalists, but they don't. Yeah, to actually be producing both is very, very difficult.
Yeah, and I would identify as I think my group is largely an experimental group. That's our focus and our main set of tools. And we collaborate, I think, with a lot of other folks who are building models they want to evaluate on various challenges, against various behavioral benchmarks. And I think that those partnerships, just to echo what you both have just been saying, are more productive the more fluent the participating members of that collaboration are in the other group's language and have mutual respect for one another's tools and approaches.
Yeah, and I'd maybe add to that, and it's sort of also an answer I might have said to the previous question, is that if you're going to be a theorist, the ability to talk the language of experimentalists is really critical. And that means, and the ability to critically read experimental papers, to be able to understand what are the pitfalls and how to look at them, look at their problems. So you really need to get pretty immersed in the biological questions that you're modeling and get to know that community of experimentalists and be able to talk with them in a way that when they talk to you, they think, oh, he knows what I'm doing, instead of, what an idiot theorist he is. So you want to get immersed. And the more you can learn about the biology, the better off you're going to be. And similarly for computationally theoretically minded experimentalists, the other way, you want to learn as much as you can, although you're not going to be a practitioner.
Is it okay, Kate, if I just also add on another thought related to that? Is that okay for the rhythm and cadence of this interaction? Yeah, and I think that at the end of the day, I think, we all, I think focusing on what you share in common with your collaborators who may have, come in with different backgrounds or, tools they wield, but we're all scientists, we all really care about theory building and understanding and uncovering the truth. And so insofar as you share that objective, you all care about developing good, correct theories that actually explain things, everyone is in some sense who's participating in these projects of theorists to some degree And many theorists today, especially those working with large task performing algorithms, like conduct experiments often with their models using the tools of induction and statistics. Many of the same tools that you might use when conducting experiments with a biological system, those experiments you might do in silica, and they're experiments you have to design well and sharply. And so there's actually quite a lot that is shared in common with respect to the kind of epistemic moves, truth-seeking moves that are made, and goals and desires actually across these two communities. And I find that the partnerships are most productive when we don't even label the members in either group as being experimentalists or theorists or something like that, or modelers versus experimentalists. But we all are, we're all kind of after the same thing. Even the kind of experiments we might devise are different, and the form that theory may take initially as we firm it up may take different forms. So for what that's worth.
Cool. So we're going to shift gears a little bit. I'm going to combine two questions I see in the Q&A that have sort of similar feels. So I'm going to read them both first. The first is, why did you decide to pursue a career in academia? And the second question that's related to this is, in the previous NMA industry panel, panelists discussed why they chose to leave academia. What do you feel are the current main arguments for remaining, both for yourself or for others more generally? Those are the two questions.
For me, the reason to be in academia is just because I'm excited about the research questions, and I have the freedom to pursue them. It's just been, it's just been excitement about understanding things, figuring things out, learning things. Academia is sort of the ideal environment for that. Now, at the moment, with things like DeepMind and Google Brain and Facebook AI, and there are places in industry where you can have a fair amount of freedom, but I don't know, people who work in those organizations would have to say for sure. But my impression is ultimately when you're in industry, you don't have the full freedom to think about whatever you're finding most interesting right now. And in academia, to some extent, you don't either, because you have to write grants, and then you need to sort of at least partially kind of do what you said you would do in the grant. So you are constrained. You constrain yourself, as you go along. But it's the freedom that really is what's best about academia, I think. And maybe, reasons why you might want to leave, or that the job doesn't end at 5 o'clock, and it may not pay as well as some industry jobs do. So, for lifestyle, academia may or may not be the best, but for intellectual freedom, it is.
Yeah, I would agree with a lot of what Ken is saying. I have a sort of interesting perspective on this because I actually recently just took a couple of years and was working full-time in industry. So got a sort of feel for, what the differences really are. I'm back at my position now as an academic at the University of Waterloo. But I think, so there was a two-part question there. So one was like, why are you where you are now? And then the second is, how do you think it compares to academia? So it might be helpful to give a bit of background. So I, basically started as an engineer, as an undergraduate, and got very interested in cognitive science, and started really just pursuing a question, like, how does the brain work? I thought this was absolutely fascinating. Neural networks were, very new, not really brain-like. I went and did a program in philosophy. So my PhD is actually in philosophy neuroscience and psychology program at the University of Washington University in St. Louis. After doing that, I worked in a neuroscience lab with David Van Essen for a while. And so, these are all very different fields, right? So I was sort of starting in engineering, doing philosophy. I did some psychology while in the philosophy neuroscience psychology program, then went into a sort of hardcore neuroscience lab. And all through it, I was just pursuing a question, really. So I think this in a way, resonates with what Ken was saying. that's what academia lets you do. You can just go through whatever discipline you want, and if you do it respectfully and learn the right vocabulary and can communicate well and all the other things that we've talked about, you can pursue a question that there's basically no other way that anyone would pay you to pursue that question. And indeed, the pay is not as good. And there are even limitations on the kinds of projects you can pursue. I think there are, basically research questions that Google can answer with their computers that we can't as academics, which I'm jealous of a little bit. But regardless, we can find other really interesting questions that Google would never ask in the first place, and answer with our much smaller computers. And ultimately, it really is a question of sort of freedom, right? And being able to just be as curious as you want. And you can entirely switch fields as an academic, and they can't fire you, technically speaking. In Canada, we don't even have to do what we say we do in the grant. We have a little bit more freedom than you do in the US. So once they give you the money, it's just like, now I can go do whatever I want for 5 years. So yeah, that level of sort of self-direction. So again, as harkening back to what we were talking about before, you need a really self-directed person, but also as a self-directed person, you get to realize your self-direction, right? You don't have to do what others are telling you. And so I think that ultimately really is the difference. And so, in the last couple of years, the company I was working at is, very research focused and doing all kinds of cool stuff, and being able to pursue projects I never could in my lab, just because they, require millions of dollars to fabricate chips and all these kinds of things. And there's a lot of reward to be had there too, but you still are ultimately working for a company. You have to make revenue. You're driven to be viable. You have to survive as a company in a way that you don't have those same kinds of really hard financial constraints and economic constraints as an academic. So I think ultimately, in some ways, this isn't news to anyone, but it's really what it comes down to in my experience. As a student going into industry, the biggest advantage is you make way more money, especially in the field that we're looking at right now, like double, right? Like it's not even close. So, but yeah, that's what you're giving up is freedom.
Okay.
And can I add something to that?
Yeah, go right ahead.
I think it complements. I really agree with everything that both Ken and Chris have said so far. And I wanted to add that I work at a university because I believe in education. I think that universities are one of the most beautiful inventions that we've ever come up with. Just the idea of a place that's meant to be a cross-section of like all of the branches of knowledge producing organizations that is just so creative and so generative, and it also is an archive for all of our knowledge. It's a beautiful thing. We had to invent it. We created that, right? And it's awesome. And it's the engine of like progress and innovation and creativity. And I think I really, really believe in that. And I believe that universities can play a huge role in shaping what kinds of ideas make their way into the world. It's no mystery to me that many of the major political and social movements of the last century originated on college campuses. I think being part of that crucible is a massive gift and privilege, and I take that role very seriously. And I think that in addition to the science that we get to do on the campuses, unlike of universities, I also think that they're amazing places to meet colleagues working in really different traditions and disciplines, and also an opportunity to really connect with students who are there to learn, where everyone's full-time job is to exchange knowledge. And that's, it's a really idealistic vision, for universities that I think day to day in the hustle bustle of keeping up with deadlines and completing paperwork, we can lose sight of. But I really think they're really special. They're really special places. They're not for commerce. They're for knowledge and education and knowledge transmission. So if you believe in that mission, then there's no better place.
Very cool.
Yeah, nicely said.
Yeah. All right, so I want to take on a question that is focused a little bit more on how you how a person might personally navigate inside academia. The question is about how you deal with sort of some of the constant pressures, which for individuals can include the need to be better, or comparing oneself to others, feeling that your productivity is never enough. The ultimate part of this question says, is it possible to be Zen in science?
Let's hear from the people with tenure.
Yeah, let's hear from the people with tenure.
Yeah, that's
I was
what
going to note the long
That's fair.
Yeah, you can become Zen after you get tenure. Yeah.
I can take a stab at this one. I read it a while ago and have been thinking about it a little bit in the background. So I think that when I am feeling most Zen-like, I am really focused internally a bit more on what the question is and what we're doing, what I'm doing and what the lab is doing to answer that question. And if I'm focused on the science, then some of the other things that cause worries fall away a little bit, enough to like really kind of find a groove. And it's not to say that I forget that, conference deadlines are coming up or that I'm on a tenure clock. It's just that it becomes possible to silence those things a little bit, and really focus on why I'm in science, why I'm doing why I'm part of this really beautiful endeavor at universities and doing research. And so I think for me, the shift to, and I do this a little bit, I try to do this a little bit every morning when I decide what I'm going to do each day. I try to be intentional about thinking about how it fits into the bigger picture. And since I started doing that, my attempt at Zen has been slightly more successful. So I think that's my answer to this question.
In terms of comparing yourself, I mean, any thoughtful person can't help but be self-questioning and insecure to some extent. But my perception is that there are very many talented people. Every year, there's a new crop of talented people on the job market, so there's a lot of people who are very good, and there's positions for a lot of people, and so everybody has really their own skills, their own special thing that make them get the results they get, the insights that they get that are just different. And so once you're at a certain level, I don't think the comparisons are very useful. There's just lots of different people who are good in different ways, and they sort of tile the space of science. And so I think if you can focus on what you're doing, your questions, your excitement, your insight, the things that you figure out, the things that you learn, that's what's going to propel you in your career. And other people are also going to get insights and exciting results, and they're also going to progress in their careers. And that doesn't diminish you in any way. So yeah, that's what I have to say.
I have this is more like a suggestion than anything. I completely agree with what you're saying about being intentional and so on. I think this might be a way of helping somebody be intentional. And that is something I think I've learned over my career, is to actually find value in some of the things that people are often stressed by, or dislike about academia. So some people don't like writing, some people don't like grants, some people don't like going and giving presentations, some people don't like this, that, and the other. And what I found is that a lot of the things I originally thought I didn't like, there's still aspects I don't like, but there's value in them too. And typically the value is trying to tell a story, right? So, I've got a story, I've got an idea, I'm trying to communicate it. And if you really care about that story and that idea, and you're trying to communicate it, then it can be, extremely rewarding to write a good paper and actually get your idea across in a way where, somebody comes up to you at some conference and says, I read this paper and it inspired this idea by me, or, something else that follows from what often people feel is kind of like grunt work, or the least exciting parts. Also true for granting. I think writing grants have become a surprisingly like creative endeavor for me, because you're essentially trying to plot out your course over the next several years, and sitting down and intentionally doing that is something that, again, often has a lot of reward in it that originally I thought, oh, it's like, I'm trying to explain to somebody, but it's like, no, I have to explain to myself. Like, I don't even know what I'm going to be doing. Then I'm not going to be able to tell anyone, and I'm not going to probably do anything particularly interesting because I haven't thought about it enough. So this is a way of maybe trying to achieve the Zen or something like that. But yeah, just trying to find those nuggets of utility or value in things which you might initially parts of the job, I think can be surprisingly rewarding.
These have all been really, really insightful comments on this question. And if you'll allow me to maybe, take it in a slightly different direction, like to some degree, I think, maybe just building what you were just saying, Chris, that like finding value in the things that you might not ordinarily find value in. For example, the kind of suffering that accompanies really caring about something, anything, literally anything in your life that's worthwhile that you really care about is very likely going to cause you some amount of suffering. You're going to work really hard. Things aren't going to work. Whatever hours they happen. And it's not going to feel good sometimes. And that's almost guaranteed, because there's risk when you like step into the unknown. That's just built in to this enterprise, this kind of work. And I think that, I've found solace in recognizing that I was far from alone in feeling that kind of suffering, and coming to some amount of like peace. Doesn't feel Zen. I wouldn't describe the state of Zen. It really does feel intense and often really, really discouraging. And really all of these, negative emotions really do happen. But acknowledging that like you're in good company if you feel those things. And that can often be just part of the journey to like figuring something out that's really hard and worth figuring out. And you may be stuck for a while, and like, that's okay. That's okay. And like, you're not alone in having felt that kind of pain before. And that some level of pain tolerance is like helpful, actually, in doing literally any kind of creative work that has meaning. And science is no different.
Yeah, that's really nicely put. It isn't, because I think when I was talking about achieving Zen, that's sort of what I was imagining, right? Is that it's not that all of those feelings have gone away, right? It's that you've accepted them, you've acknowledged them, but you're choosing to do this thing because it also brings you a lot of these joy. Yeah, suffering is part. Okay, maybe I don't have a good understanding of Zen. The philosophy, you're right. I have read that before. Okay, we'll leave that to the philosophers though. So I feel like Judy actually just sort of answered this question, but maybe we can extend this conversation a little bit longer. I see a question in the Q&A section that says, what are your suggestions for managing and handling failures during your PhD and the rest of the academic career path, including rejections of a variety of sorts? And how do you deal with that? Or what are your suggestions for resilience?
This one has another long pause. I think the length of the pause tells us something about the question. But anyways, this is one that you just have to be robust. Like there's kind of no way, but everyone gets rejected, right? Everyone remembers the things they didn't win, the papers that they thought were amazing that got rejected from not just the first journal, but many journals. And there's really, there's no other way to put it than you kind of have to trust in your own judgment about, whether it's worth continuing to pursue that and, keep going, or to take the external suggestions to do otherwise. And I think in general, you need to be far more on your own, in your own side than listening to the critics, right? So this is just kind of what robustness is. And sometimes it really feels like, you're doing something which you shouldn't do, in the sense that so many people have told you this is a terrible idea, or it's failed so many times, or whatever, that, yeah, you're probably being unreasonable. Like, it feels like you're almost being unreasonable in continuing to pursue this project or this particular idea, or whatever. But that's also where the breakthroughs come from, right? So, you know, this is just something you kind of get a feel for it, but you definitely have to be robust. You can't just can't listen to all the illegitimus non carborundum, right? Don't let the bastards get you down. That has to be the main saying you should paint on your wall.
All right, I think we'll leave that one at that very cleverly translated Latin phrase, unless Judy would like to. I'm sorry, Judy, when I pop the questions up, I can't see your nonverbal cues.
Oh, sorry. No, I mean, I'll be brief. I promise. I know, no, not at all.
No, you don't have to be brief. We brought you on here to speak.
It's like it's you know, so there's like the, you know, there's one dimension which is like in time, and the other one is kind of at any given time point. And over time, you know, I struggle with this. Failures and rejections get me down. I always take them personally. I know I'm not supposed to, and I do anyway, and it's awful. And I think I've just come to realize that, like, it's going to feel really bad intensely for a period, and then, right, as Chris was saying, then you pick yourself up and you just have to move on. You have to move on to other things. There's just really no way around it. Or drawing too strong of inferences from those for those kinds of signals. And related to that, I think, like, diversifying your portfolio, it's like a phrase borrowed from investment advice, but you know, like having, you know, different bets that you're making on nature, I think is really helpful, right? It can be really risky to have everything riding on a single approach, a single set of experiments, or, you know, whatever way you might organize your work. But if you can, and you have the capacity to, and the infrastructure supports it, you know, being in a place where you're able to make a couple bets at a time, say in grad school, and that can help to buffer against a particular lead not working out. At least in the area that I work in, it's cheaper to make bets and for them to fail, and so you can make more bets in parallel. I know in some fields that are maybe resource intensive in a different way, that can be really difficult. And so finding some way to kind of broaden the ensemble of bets that you're making can be another way to make any particular rejection or failure not sting so fully.
All right, so we're going to shift gears again. One of the students asks, how do I know when I'm prepared to enter a PhD program? I feel like my knowledge and skills aren't developed enough to lead an individual project.
You don't have to lead an individual project when you start a PhD program. That's why you have a mentor. I mean, I think you need a basic undergraduate education and motivation, and it helps very much to have research experience. I think for our program, it's almost essential to get into our program to have research experience. Partly because it's a way of knowing that it's for you, and conveying to us that you know what you're getting into, and partly because it's also a way to, in practice, to get recommendation letters that are going to help you get into the school you want to get into. Those are going to come from your research advisors. But you don't need some particular level of knowledge about some particular thing. What you don't know, you make up in grad school. You take courses when you need to. You learn from direct one-on-one with your mentor, with your other students and postdocs. You learn what you need to know to do the research, and doing the research is really how you learn. So that's, when you're done with undergrad and hopefully have some research experience under your belt, then you're ready for grad school.
Okay, on a related note, at the PhD level, in neuroscience generally or in computational neuroscience specifically, is it reasonable to suggest a research project, or is it generally that supervisors will provide a topic for you to work on?
This is extremely lab dependent. So yeah, in my lab, so well, I guess computational neuroscience is probably different in this regard to some extent too, but in my lab, I let students pick almost inevitably because I really do believe in that. You have to really like what you're doing, and that I'm trying to train someone to be an independent researcher. So, that's your first chance to pick like your big independent research project should be something that's really driven by you. You've been in my lab for a while before you make that choice, so you have an idea, what kind of stuff we tend to do and everything. But yeah, I would generally encourage people to really have a hand in picking what their project is. That can't be done in every lab though, for sure. And I think experimental ones, often they're a little more specialized in the kind of work that you can do in a particular lab.
Can I ask a specific follow-up to that response, Chris? Briefly before Ken speaks, is that you said that students will often pick a project in your lab. But that they do that after they've been in the lab for a while. So do you have ways of providing students like things to get started on before they work, or are they taking coursework? What does that trajectory look like for a student picking a project in your lab?
Yeah, for sure. So I think as Ken was pointing out, essentially, the first couple of years of any PhD is you doing a whole bunch of background work and learning and research and everything. At the same time, if you're in my lab, then we have lab meetings every week, and you get to see all of the other work that's going on in the lab. So you can see here's a sampling of different projects that people have picked. We also have journal clubs and things, so we get we read broadly about other kinds of questions people are asking outside the lab. My lab tends to be kind of foundationally focused, so it's like if there's any part of the brain that you care about, we've got tools where you can try and apply them in that part of the brain and see if you can learn new things. And so that's a bit of an advantage. And so really the students are kind of learning that set of tools, both through coursework and projects, collaborating with other students on their projects, giving them a deeper sense of what exactly is going on at a PhD level or even with postdocs or anything. So it's really that kind of experience that they're gathering in the first few terms that they're in the lab, and then I think that provides them generally with a pretty good foundation for picking, and also seeing speakers come in and seminar series. Anyway, so just all this kind of exposure.
I also just want to say, I want to say it can vary from, it varies from student to student. I mean, there's some students who absolutely totally define their own projects. And so long as they make sense to me, I'm happy with that. And there are students that that don't, and that's fine too. I typically will suggest, some set of possible problems or directions to work on, and hope that the student will pick the one that they find most exciting. But yeah, we can definitely give you problems in that way, or a set of problems that you might think about and choose from. But if you've got your own ideas, many of us welcome that. So it can go either way.
And I'm based in a psychology department, which I think runs their PhD programs in a way that I think is often different from the way that neuroscience programs are often run. It's less common for students to come in and do a rotation through multiple labs before committing to one. In my department, anyway, students are admitted with a particular primary advisor already from day one, and the first year culminates in a first-year project. And so there's a really strong empirical focus and hitting the ground running. And so usually during the admissions process is where a lot of these questions around research fit, and like whether the kinds of questions and phenomena and topics that really excite a prospective student really line up with that of a prospective advisor. A lot of those questions are raised during that process to set that student up for success in their first year project, which then will hopefully put them in a better position to pursue their dissertation work. So, in practice, it ends up being a dialogue that begins from the first cold email before like an application is, sent in, and before, and it sort of continues through the interview, continues into the summer, if you decide to join someone's lab, and then through the first year, you're developing research ideas in dialogue with your mentor. So it never really feels like it's all one person or another devising the project. It's like this ongoing conversation. So if that helps.
All right, so we're sort of nearing the end of our hour, and I want to do something a little bit different. We'll have time for one or two more questions. So this question is still from one of the students. It was asked very recently. So it says that I feel like the current academic research system is quite outdated. What are some key areas you guys think we should improve on? So I feel like I want to ask this question because I feel like this group of people, particularly given what Judy said, we have a very collectively are excited about universities and the research system we're part of, but obviously it can improve in a variety of ways. Like what kinds of changes are happening now, or what kinds of changes would you be excited to see as we move into the sort of next generation? Because we're talking right now to the next generation of scientists.
I've had an opinion about this for quite a long time, and it's essentially that there should be a deeper integration between the theoretical and experimental sides of neuroscience. So this is like particularly a neuroscience perspective. So something like what you have in theoretical physics, where a lot of theoretical and experimental physicists take very similar courses. They have, they're very strong in a shared vocabulary, technical vocabulary, and quantitative skill set, and then tend to specialize, right? And as we were saying, it seems to be hard to not specialize in theoretical neuroscience, or in neuroscience, right, to experimental or theoretical. But to me, the training still is just way too divided, in the sense that you go kind of through a biology program and to become an experimental neuroscientist, and you go through, some technical engineering, physics, math kind of program to become a theoretical. That's just not right for the future of neuroscience, in my opinion. So that would be the thing. And we actually tried to start an integrated program at Waterloo, and we had problems with the administration. It didn't happen. But I really wish there was more of that out there than there currently is.
I guess the main things that occur to me in response to that question are just the movements that are very active towards open science, data sharing, and towards open access, changing the review system, changing the publishing system to be not for profit and open, and improving the review system. And eLife is doing some very nice experiments with ways of improving the review system. So I think there's a lot of very active movement in those directions. It's hard. There's a lot of inertia in the existing systems, and it change is slow, but there's a lot going on, and it is coming from the young people who are really pushing it.
And I'll try something really brief, which is, I'll complicate something I was saying earlier about how special universities are, and that what I do wish for in the fields of psychology and neuroscience were that there were more of the kind of revolving door between the academy and industry than there is today. What I see in computer science is really wonderful, because I think as scientists, there are questions, deep questions, timeless questions that we care about, but I think it also really serves our core aim to also figure out whether our theories really survive in the real world when they're deployed. I study human learning, and I really, really care about that. And many of the tools that we have to study human learning aren't subjected to those strong tests. Could you really engineer learning environments and systems and that really support that? Your theories really make predictions at scale. And I think that opportunities for individuals in cognitive science and psychology and neuroscience to be able to sample those different experiences in different work contexts and be able to return to the academy and not be a one-way street from academia out and not back in the way that Chris was able to do recently, I think would be really fabulous and healthy, actually, for basic research in cognitive science. So that's one thing that I long for.
I'm going to go ahead and answer this one because I want to point out that you guys are actually participating in a group of sort of faculty members' wish for the future right now. NeuroMatch has been this sort of grand experiment. It's changing who gets access to computational neuroscience training. And I think that for me, in a broader sense, I'm excited about all of these movements that are broadly fall under science communication and open science and changing sort of access to science. And so I guess on that note, I really want to thank all of our panelists for joining today. All of your comments and answers to these questions were super insightful, and we really appreciate you joining us for this
Actually,
hour.
could I just say one thing before we quit, which is because my mind is sort of the most important advice I would want to give people, which I haven't
Oh,
said,
yes.
is just you can't strategize about what's the right thing to work on in terms of anything except your own excitement. You need to follow your excitement and your interest, because that's what gets you out of bed in the morning. That's what gives you the resilience. That's what gets you through the hurdles. That's what keeps you going. And so that's number one. And number two is it really is important to work with, to the extent that you're capable of, you don't always have power over this, to work with people that you trust and respect. If you find, if you think, oh, somebody's work looks really interesting, but they're a bastard, forget it. It is not going to turn out well for you. So those are the two things I would say. Follow your excitement, try to work with people that you trust and respect.
That's also a really great note to end on.